Okay, this series now we're going to concentrate on differentiating trig functions. A few good questions now. If I go back to the top of my page, I will take this, which is from our front of our exam sheet. So remember we have this. And what is that saying to us? Well, it's saying when I differentiate, I know sine becomes cos, I know cos becomes negative sine. So right away, we don't even have to remember what's happening because then negative sine becomes negative cos becomes positive sine. So we don't have to worry about remembering that. And it's saying here that we multiply through by the differential of the bracket. Here it's just got ax, here we've got a slightly bigger bracket. We're multiplying through by the differential of the bracket. So you don't have to remember anything. That's pretty good, isn't it? But I would usually just write that I know sine differentiates to cos, which differentiates to negative sine, which differentiates to negative cos, and then that series just repeats over and over again. So then sine, etc., etc., and this one would finish off with negative cos. So this little, differential, this little list just keeps on going forever and ever. Sine, cos, negative cos, sine, cos, in the same way that up here there's a sine, cos, negative cos. That's your differentiating, and that's your integrating. So first of all, I remember that, just because I prefer to think on that than these. And then also, we're multiplying through by the differential. If you've got that, this is actually quite straightforward. Okay. So let's write our question out. I've got f of x, and I've got 4 sine 3x, take away pi over 3. Okay. So let's differentiate sine. Sine becomes cos, and as always, inside the bracket stays the same. Excellent. Doesn't look like a 3 rows, does it? And my 4 stays where it is as well. And I'm going to multiply through by the differential of the bracket, which is just 3. Because this is a number, numbers would disappear when we differentiate. 3x becomes 3. So for my final line, I'm going to say I've got 12 cos 3x, take away pi over 3. Fantastic. But I need to know what's the differential at pi over 6. Okay. So then when we're at pi over 6, I'm substituting in pi over 6. So 3 times pi over 6, take away pi over 3. All I've done there is taken the x, put in pi over 6. So what does that give me then? Well, 12 cos is staying where it is. This is going to come out as 3 pi over 6. So let's just keep it in 6, shall we? And I'll change this to 6 as well. And that'll be 2 pi over 6. Just times the top and bottom by 2. So 3 pi take away 6 divided by 2 pi over 6 is going to give me 12 pi over 6. 3 pi take away 2 pi leaves me 1 pi. Okay? Fantastic. And at this point you have to use your exact value triangles. So I'm just going to draw them out very crudely. Let's have a look. These should be ingrained right in your head. You should absolutely know these on the back of your hand. So I've got a 45 one. And I've got mine. I do the 30 here, and I put that next to the root 3. I always remember the 3's go together. And then 60 and 1, and that has to be 2. Check out Pythagoras. Square it, square it, square it. Yep, that makes sense. The other thing I'll write down is that I know 2 pi is 360 degrees. So pi is 180. So if I'm looking for a sixth of that, I know that I've got 180 divided by 6, which would be 30 degrees. So cos of 30 degrees. Well, there's no 30 degrees there. Cos is the adjacent over the hypotenuse. So I'm going to have 12 multiplied by the adjacent over the hypotenuse. Cos of that equals adjacent over hypotenuse. Very good. 12 divided by 2 is 6. And that's me finished. Not an awful question at all. So yeah, definitely worth knowing. 3 marks. It's not a quick question, but I wouldn't say it's too tricky though. So I hope that's helpful, and we'll try and squeeze another one into the video. Let's go for the next bit. Here we go. So look at that. It's the same thing again. Yeah. So let's just write down, I know that sine differentiates to cos, differentiates to negative sine, to negative cos. Okay. So when I say h of x is 3 cos 2x, the h dashed Cost becomes negative sine. The bracket stays the same. The 3 even stays the same. But I need to multiply through by the differential of the bracket, which is 2. So I'm going to end up with negative 6 sine 2x. Now I need to substitute in this time my pi over 6. So it's going to be negative 6 times sine of 2 pi over 6. So 2 pi over 6 is just pi over 3. Fantastic. So again, I would draw my triangle out. I'd say I've got 30. And this is, do the triangles all the time. Don't just, oh, I remember that from the last question. Draw it out again, because it gets it in your head. You remember it now, maybe you won't remember it next time, So it's worth just training yourself to always have these, write out the things you need to, because it will stick in your memory a lot better than just, oh yeah, I've kind of got that. Just always get that process in your head. So pi over 3, 180 divided by 3, so that'll be 60 degrees I'm looking for. So this time I've got sine of 60, so there's sine of 60, there's 60. So sine of 60 sine would be the opposite over the hypotenuse. So I'm going to have negative 6 multiplied by root 3 over 2. So negative 6 over 2 is negative 3 root 3. Look at that, we've got 2 of those questions done. So you're getting your marks for the first line. If I'm not exactly somewhere with marking scheme in front of me, but the methodology we're doing is the cost becomes negative sine, the bracket stays the same, the number stays the same, you're multiplying by the differential, which, as we discussed, you are given. You're told that you multiply through by the differential. That's what this means. If I've got 5x here, differential of 5x is 5. And yeah, remember your radians, remember your triangles. I don't think I'll get the next one done. That might be too much. Let's see. I'll try. No, I won't. I'll put it in the next video. And this will be the last one.